Assalamu alaikum. We are going to look at solubility, but before we do that, we need to look at what the meaning of solution and the different types of solutions that are related to solubility. A solution is actually a mixture of solute and a solvent. And then the different types of solutions that are related to solubility are the saturated solution. This is actually the maximum amount of solute that can dissolve in a solvent at a given temperature. And then we have the unsaturated solution, which is a solution that can dissolve more solute at a given temperature. The last type of solution is the supersaturated solution, which is a solution that contains more solute that can dissolve in a solvent at a given temperature. Now, what is solubility? Solubility can be defined in two different ways. One, it is the amount of solute to dissolve in a solvent at a given temperature, or we can define it as the concentration of solute in a saturated solution at a certain temperature. It is expressed either in mole per dm cube or in gram per dm cube. Now, the factors that could affect solubility can be the nature of the solute or the solvent, temperature change at the same time, the common ion effect. And then sometimes when you want to increase the rate of dissolution of any solid in the liquid, you can do it either by stirring the mixture, by grinding the solid into powder, or by heating the mixture. Now, solubility can be calculated using these formulas, either using the first one, which is solubility is equal to amount over volume, or it is the same thing as mass concentration over molar mass, or we can also use the formula mass over volume. And then the one thing you need to remember is the formula for calculating amount, which is mass over molar mass. Here are some worked examples. The first one is, what is the solubility of X in mole per dm cube if 25 centimeter cube of its saturated solution contains 4.0 gram of X? In bracket, the molar mass of X is given to be 60. The first thing you need to do is to bring out your information. In the question, we have our mass to be 4 gram and our molar mass to be 60. The volume given to us is 25 centimeter cube, and we need to divide it by 1000 in order to change it back to decimeter cube. Now, using the formula, solubility is equal to amount over volume. We need to know what is our amount because the amount is not given to us in the question, but we can get it. And the formula is mass over molar mass. From the question, we know our mass is 4 divided by our molar mass, which is 60. It's going to give us 0.067 mole. Since we know what is our amount, we can simply come back and calculate our solubility. The amount is 0.067 divided by the volume, which is 0.025, and the solubility will be 2.68 mole per dm cube. We can also use the second formula, mass concentration over molar mass, and then we make mass concentration, but we don't have the mass concentration in the question, so we can easily look for it. Mass concentration is mass over volume, and from our question we know the mass is 4 and the volume is 0.025, so we substitute them in the formula and we get 160 gram per dm cube. Since we know our mass concentration is 160, we come back and substitute it in the formula for solubility, which is mass concentration divided by molar mass. The mass concentration is 160. We divide it by 60, the molar mass, to give us 2.67 mole per dm cube. So if you compare the first solution to the second solution, you notice that the answers are the same using different methods. Another example here is 14.9 gram of a salt Z dissolves in 250 centimeter cube of distilled water, gives a concentration of 0.80 mole per dm cube. Determine the molar mass of the salt in gram per mole. Now we are looking for the molar mass. And from the question, we know that solubility is mass concentration over molar mass. Then the molar mass, now we need to make molar mass the subject of the formula, since that is what we are asked to look for. So now it's going to be mass concentration divided by solubility. From the question, our solubility is 0.80 mole per dm cube. Our mass is 14.9 gram. And then we also have our volume given in the question, which is 250 centimeter cube. But remember, we need to divide it by 1000 in order to change it back to decimeter cube. And after doing that, we got 0.25 decimeter cube. Now we need to look for mass concentration, because mass concentration is not given to us in the question, and the formula is mass over volume. And in the question, our mass is 14.9 divided by volume, which is 0.25. And when you do that, you are going to get 59.6 gram per dm cube, which is our mass concentration. Since we now know our mass concentration, we now come back to the formula. Molar mass is equal to mass concentration over solubility, and our mass concentration is 59.6 divided by the solubility in the question, which is in mole per dm cube, that is 0.80, and our final answer is going to be 74.5 gram per mole. Then the third question is, if the solubility of potassium hydrogen trioxocarbonate 4 is 0.4 mole per dm cube at room temperature, calculate the mass of the salt in 100 centimeter cube of the solution at this temperature. And in brackets, the molar mass of this salt is given to be 100 gram per mole. So the same thing, we bring out the data. Solubility is 0.4 mole per dm cube. Our volume in the question is 100 centimeter cube. Always remember to change it back to decimeter cube by dividing with 1000, which is going to give us 0.1. And then the molar mass of this salt is 100 gram per mole. Now, using the formula, amount is equal to mass over molar mass, we make mass the subject of the formula because it is mass that we are asked to look for. So mass is now going to be amount times molar mass. Now solubility is equal to amount over volume, and then we don't have the amount in our question, so we make amount the subject of the formula, which is solubility times volume. And in our question, the solubility is 0.4 and our volume is 0.1. When you multiply them together, you are going to get 0.04 mole. Since we've gotten our amount to be 0.4 mole, you now come back to substitute it in the first formula, that is mass is equal to amount times molar mass, and our amount is 0.04 multiplied by 100, which is the molar mass, and our final answer is 4 grams. Then the next thing is we are going to look at the solubility curves. Now, what is this solubility curve? It's nothing other than a graph that shows how the solubility of a substance changes with temperature. And on that solubility curve, anything that falls on the curve is what we call a saturated solution. And any figure that falls below the curve is what we call the unsaturated solution, while the one that falls, any figure that falls above the curve, it's what we call the supersaturated solution. So this is how we read the solubility curve. An image here is used to display a solubility curve. This one is a normal solubility curve. If you look at it, the one that falls above is the supersaturated, the one that is on the curve is labeled as saturated, and the one that is below the curve is labeled as unsaturated. Now, this is another sample of how the different solubility of different salts is displayed on the same curve, so you can take your readings at any time. And lastly, what are the applications of solubility curves? In summary, the uses. Why do we use solubility curves? The first is to compare the solubility of different salts at different temperatures. We can also use it to determine how much solute will crystallize out if a solution is cooled. And then we can use it to predict whether a solution is saturated, unsaturated, or supersaturated. And lastly, we can also use the curve to separate and purify mixtures of solids. So this is where I'm going to stop today till we meet in the next class. Thank you.